Hi folks, I've been using my Raspberry Pi 5 as a desktop for a few months now, and I would like to know whether it's a better investment than an equally priced mini PC, let's say $150, and has about the same architecture, which means that it has an SSD drive, it has 8 gigabytes of RAM, it also has got a few USB ports, HDMI outputs, and this is what we want to know. What is a better investment? So we already know that Raspberry Pi 5 is a very good computer if you want to explore computer science and if you want to learn something new, because it's bare and you basically have to assemble your computer entirely yourself, and this is probably the most interesting part that you can do by yourself to get a very good introduction to computer science. There are
many mini PCs that their prices are comparable to Raspberry Pi 5's price, but the advantage of these mini PCs for desktop users is that they are fully assembled and they also come with pre-installed Windows operating system, at least most of them. But Raspberry Pi 5B is more for computer enthusiasts, but it should have been also cheaper. But let's see what the results of the speed test might be. I went to cpumonkey.com webpage where you can make your own actually you can compare any processor you would like, and you can see the difference between their technical details and also between their speeds measured with different tests. Let's take a look. What's interesting here is that both processors have 4 cores and both can run up to 4 threads at the same time, which means that each core runs one thread. So they are single thread and they are not using multi-threading, as we'll also see later in the comparison. We can see here that Intel N100 processor goes up to 3.4 GHz and it supports up to 16 gigabytes of memory, while Raspberry Pi 5B only goes to 2.4 gigahertz and supports up to 8 gigabytes of memory. But it must be noted that Intel cannot be overclocked, but Raspberry Pi 5B BCM2712 system on chip can be overclocked to 3 gigahertz, and yeah, it's faster if you do this. About 25% with the CPU and about 20% with its graphics core. We can see this technical data. What's interesting here is that Intel N processors are based on Alder Lake N architecture, but Broadcom BCM 2712 is based on Cortex A76 processors. I don't believe this because I think that both are intended for actually small desktops and also mobile. I've already seen mobile computer, a laptop with Raspberry Pi 5. Okay, we can see here what we've already talked about. What's interesting here are these turbo frequencies that has to be explained. Actually, Raspberry Pi 5 can run at the lowest frequency of 1 gigahertz, and it can comfortably run at constant frequency of 2.4 gigahertz. But you also have throttling, so you may leave it to run at any frequency between these two values if you want to spend less energy when the processor is does not need to run at the highest design frequency. Probably the same is with Intel, we can see it here, but there's the difference between when the processor is utilizing 4 cores and when it's just more or less utilizing 1 core. It depends on actually what application you have that you're running. If you have an application that is not able to use multiple processes and it's just running as a one process with a single thread, this might be useful. But for most of the application, this result is more important. So if you overclock Raspberry Pi, which we obviously can do with Intel, we can also get with Raspberry Pi to 3 GHz. Now let's take a look to the graphics processing unit, GPU. Intel has an inbuilt UHD graphics with 24 compute units, but with the Core 7 has, I guess it should have been 12, because it has 12 compute units or cores within this video Core 7. It's running at 0.8 GHz or 8 MHz, while UHD graphics uses throttling, so when it's not needed, when the high speed is not needed, it's running at 300 MHz or 0.3 GHz, and when the most of its power is needed, it can run at 0.075 GHz or 750 megahertz. What's also interesting is how much memory can a graphics card utilize with Broadcom Video Core 7. It's only possible to utilize 4 gigabytes, while UHD graphics can utilize up to 8 gigabytes, which means that actually each of the graphics processors may use half of the maximum of computers' main memory to support graphics. Here we have also what either graphics core can encode and decode. I must say that encoding is only important if you are making your own music, you are making your own video, or converting video and music formats. Otherwise, decoding is used, and we can say that almost the same formats are supported, except for codec AV1, which is not supported by Video Core, which means actually that central processor must kick in if you want to make this format, or if you want decode, which is usually slow and takes a lot of computers' capabilities, and it usually doesn't spell a very vivid graphics. Now let's take comparison to the Center Unix characteristics. The maximum supported run we can see here, we have already mentioned this, but this is more important. It's memory bus. We have maximum bandwidth that memory bus can run. We can see that Intel N100 processor also supports DDR5 RAM, and I believe that this value is for this kind of RAM. So you put this in, which I'm not sure whether we're getting this with the cheapest PCs, but DDR4 RAMs are a little bit slower, so you've got 76.8 gigabytes, while you can see here that Raspberry Pi 5 BCN2712 only supports DDR4 RAM, some kind of version of it. The both memories have single channel, which means that there is no memory interlacing, so each memory interlace, so if you have two modules that you can interlace access to, you can actually, with the help of cache, you can achieve twice or three times, depends on how many memory channels you have, of the speed to the main processor. This is very effective using more channels, but here we only have one channel, which is typical for some older laptop computers. They all had one channel, so you don't have to bother with this. But we can see the obvious difference between memory speeds. Intel has much higher upper maximum speed than Raspberry Pi 5B, as we can see here. If we compare the caches, we can also see that level 2 cache with Raspberry Pi 5B BCN2712 is only 2 megabytes, while Intel's is twice this size, and level 3 cache is also 3 times as large. This is obviously possible because if we take a look here, we can see actually that Intel is made with a much more precise technology, with more advanced chip technology. It's 10 nanometer versus 16 nanometers. So larger transistors in this case mean much more heating, and they can also not achieve so high speeds as with 10 nanometer technology. So it's actually also the difference in performance, can be explained by this. We can also see PCIe. This is bus to communicate to internal and external devices with Raspberry Pi 5B. It's version 2.0. It's slower. You can set it to version 3.0, which is actually supported by Cortex A76 cores, but unfortunately it's not running stable with this, so it's not recommended to do this. But with Intel this is a standard. On the top of this, Intel has got 9 PCI lane bus, while BCM2712 only supports 4 lanes, and these 4 lanes are only used to communicate to RP1 chip, while communication to the outer devices, to external devices, is through 1 lane PCIe bus. So the speed between RP1 chip and BCM2712 is de facto 2 gigabytes per second or 20 gigabits per second. This conversion rate of 10 is not because byte wouldn't have 8 bits, but because there are usually 2 additional bits that are used on average to handle the protocol. So it's conversion rate 1 against 10. We have also here a much faster PCI bandwidth. We can see it's 8.9 gigabits per second, which also contributes to this results that we can observe here. We can see that on average Intel processor N100, it's about twice as fast as Raspberry Pi 5B. Okay, here it gets to 60% only because of the memory bandwidth, because Geekbench 5 is heavily reliant on a memory system, while Geekbench 6 also includes CPU power, how much computations can a CPU core do, and we can see that with a single core running on some of a computational problem, Raspberry Pi 5B BCM2712 can achieve about 65% of what Intel processor N100 is capable of. But with multiple core, it seems that it's also very important how big the caches are, because each core has to fetch instructions, has to write data and so on. And if you have a smaller cache, there is more need to access main memory, and if there are concurrent accesses, it actually blocks certain cores. They have to wait and so on. So this is the results. It's about 56% for Raspberry Pi 5B compared to M100 processor. Here we have another comparison. This is graphics performance with a single precision in gigaflops, and we can see that actually Raspberry Pi 5B can achieve about 42%, which is approximately 2.5 times less than Intel's UHD graphics can achieve. So this is more or less it. Unfortunately, we can say that there would have to be another evolution of Raspberry Pi. Maybe Raspberry Pi 6 would be an equal match to a mini PC, we'll see. But of course, there are many technologies that are right now not inbuilt in Raspberry Pi 5 BCM2712. For example, this vector computing that might be very interesting in graphics and virtualization support. If you want to run applications that were built for a different architecture, this is very interesting with ARM architectures, because they have to run programs for actually from Intel architecture, because there are many more programs than for ARM, which is new in PC world. And here we have also algorithm that is hardware supported by hardware. It's actually encoding and decoding algorithm for actually to encode data to prevent it from being okay when you transfer it and so on. Here should be no hardware support, but I know that there is hardware support for certain encoding and decoding algorithms like IES. Here we see the operating systems. All these are supported in production for mini PC with Intel processor 100, but with this is not supported. Windows 11 on ARM is not supported with Raspberry Pi 5B. It's only supported in a preview mode, so it's not a production mode, and it doesn't have full functionalities, so it's not really useful, I must say. But Linux is even more useful than with the classic PC at some times. For example, Kali Linux or whatever you want to have on your computer. Okay, these price tags are more of oriental nature, because this is what you're gonna pay for a Raspberry Pi. This is about, okay, it's $80, but you cannot buy BCM2712 separately, so this is the price tag for a whole computer, for a bare computer, without a case, without SSD drive, without an extension card, without a cooler. So I've got one like this, and I took a case from my Raspberry Pi 5, from my Raspberry Pi 3, and then I inbuilt in a Raspberry Pi 5, and I used an old ventilator from discarded from a broken power supply also to make it work. But of course, if you want to make your computer, you can get it for $80, but the fact is that I've also had to buy a sound card, and this one cost me about €6. So you can see that actually that here is the price of a whole system, but I would say that usually you won't get it, at least not in Europe, under €150. Maybe in USA that you can buy it for $130 as a whole. It depends if there are any discount prices and so on. So we can see that these systems are quite comparable regarding desktop use, and you have to think twice if you're buying Raspberry Pi. But I must say that you don't need antivirus software with Raspberry Pi, but with a regular PC you will need it, because there are a lot of malicious code out there, but for Raspberry Pi 5 currently I cannot say
for
that
today.
there is
Press
any
subscribe and like button
really
if you like today's stuff. The next video is coming soon.
Your computer. And even if it were, your computer cannot be completely destroyed, because it's open architecture. You can reload your EEPROM with a new bootloader, with new primary bootloader, and you rewrite your SD card or whatever media you have, and you are good to go. So that's it.
That's it for today. Press subscribe and like button if you like today's stuff. The next video is coming soon. Bye.